All right, today we're going to talk about different types of reactions. And so your goal by the end of this video is to be able to look at a chemical reaction or a chemical equation and determine which of the five types of reactions it is. This is helpful to us because this will help us to be able to predict what products we're going to have whenever we mix certain chemicals together. All right, so the first type of reaction, so on your notes, you can go ahead and add this in. The first type of reaction is what we call a synthesis reaction. To synthesize means to make. And so you're going to take basically two different elements. You're going to take an element and put them together to form a new compound that's going to have those two elements bonded together. All right, so an example would be we have hydrogen as a pure element and oxygen as a pure element, two different, they're not combined because that plus sign is in between. And when we put them together, they are going to form H2O. Second example was if you have pure sodium and you have chlorine, when you combine them and they decide to bond together, they will form sodium chloride. All right. And so it's an element and an element. So two things forming one thing at the end. So two becomes one. Here's a cartoon that you can think about just to kind of help you visualize it and analyze or visualize and analyze what's happening. So you have a cat and a fish. The cat eats the fish, and now there is one happy full cat at the end. So you had a cat and a fish, two different things, and then at the end you have one new thing. That is a synthesis reaction. Decomposition is the opposite of a synthesis reaction, where in this case you're going to break down one reactant into two or more products. So one becomes two. So if you have a compound AB, what's going to happen is that A and B are going to break bonds and they are going to separate and be two separate things at the end. So the cartoon analogy is if you have just an egg and that egg hatches. So before you have an egg, and then afterwards you have an egg shell and a baby chick. That would be an example of a decomposition. To break down is what decompose means. So from a chemical standpoint, you have H2O. The hydrogen and the oxygens are bonded together. We're going to break those bonds apart and separate them, and we're just going to have hydrogen and oxygen, but separated by that plus sign because they are no longer bonded together. Pay no attention. Well, you know why there's twos here, because those are diatomics, but you don't really need to worry about that too much right now. We're just learning how to classify and identify them right now. Second example from a chemistry standpoint is CAS. In this case, you have CAS bonded together, and then it'll break apart into its individual pieces, Ca and S. So decomposition, one breaks into two or more sometimes. The third one is combustion. All right. The key thing with the combustion right here is you have an oxygen. You must have an oxygen reacting with a compound in order to have a combustion reaction. The products of a combustion reaction are always are always water and carbon dioxide. Those are two products you will always get. Now, the key thing is that we say it reacts with a compound. Usually, these are going to be what we call hydrocarbons. If you think about what that word looks like, hydro maybe means hydrogen, carbon means carbon. So a hydrocarbon is any compound that has some number of carbons and some number of hydrogens in it. Sometimes you can also have like an OH at the end, but it must have carbon and hydrogen in it, always reacting with the oxygen in the air to produce this combustion reaction where your products are water and carbon dioxide. Okay, so here's your example of CH2. It's a hydrocarbon because it's made up of carbon and hydrogen. in some kind of a ratio, reacts with oxygen, and then it's going to produce water and carbon dioxide always. Okay. A second hydrocarbon, it's got carbon, hydrogen, and then it's got a little extra OH group on there, which is fine because it does have a carbon and hydrogen. That's the important thing. Combines with oxygen, that's key too, must always have oxygen. And then again, your products are always water and carbon dioxide. So your key pieces to know is that it has to react with oxygen, and your two products are always water and carbon dioxide. Our fourth type is a single replacement. All right, a single replacement is when you have a single element, hence the word single replacement. So a single element replaces an element in another compound. Okay, so you have a single element represented by A, you have a compound represented by B being right next to and connected to C that will yield B, and then so another element, and then a new compound. And what's going to happen on this is the A is going to bump out B, and now A is going to be combined with C. So it took B's place, and now B is going to be all alone. Okay. Um, the example I have from a cartoon standpoint is you have a steak and you have a dog with a bone. The dog obviously would prefer the steak, and so is going to drop the bone and replace the bone with the steak. Okay, so the steak replaces the bone, and now the bone is left all alone, and the dog walks away with the steak. So, from a chemistry standpoint, you have again a single element, zinc, reacting with a compound. What's going to happen is the zinc is going to bump out the hydrogen, and poor hydrogen now is going to be all by itself, and the zinc is now going to be with chlorine. Sometimes people like to think about these like dance partners, right? Zinc is dancing alone along the wall, watching from the outside, is going to come in and bump out the hydrogen, and now dance with Cl, and hydrogen is going to be off by itself. Okay. You'll notice here chlorine is going to replace bromine so that it can be partners with sodium. Okay, so now sodium and chlorine are together, and bromine got kicked out. And so now bromine is by itself. Okay, again, that is a single replacement where a single element replaces an element in another compound. Okay, make sure you write that down in your notes. Pause this as you need to. A double replacement is going to be now where you have elements in each compound. So you're going to have two compounds. And in this case, I have A and B and C and D. And what's going to happen is the A is going to push out the C, and they're going to switch partners. All right. So A is now going to be partnered up with D, and C is now going to be partnered up with B. So they just swapped places, swapped partners. So the cartoon example would be this rabbit with a steak and a dog with a carrot. Clearly, they want to make a swap, and so the carrot is going to swap over to the rabbit, and the rabbit is going to then swap the steak over to the dog. So when you look at these two examples here, the silver and the sodium chloride, those are your two positive ones. Positives will always bump out positives. And so the Ag is now going to become partners with the Cl, and the sodium is now going to become a partner with that nitrate polyatomic ion. And then potassium, bromide, and copper to nitrate. The copper, again, that's the positive one, is going to want to swap places with the other positive one. So now potassium is going to be with the nitrate, and copper is going to be dancing with the bromine, right? So that is the key idea. Okay, we had synthesis, decomposition, combustion, single replacement, and double replacement. So I've got four cartoons here. This is going to be similar to an activity that you're going to do here in just a moment. you're going to name the reaction represented in these cartoons. So I want you to just take a moment and pause and tell me, what do you think number one is going to represent? An apple tree breaks down into a tree and then apples. Number two, you have a penguin with a top hat and a pig with glasses. And then they're going to switch. The penguin is going to take the glasses and the pig is going to take the hat. Okay. Number three, you have pepperoni and then you have a pineapple pizza. Just my personal opinion, but why would you ruin a pizza with soggy, warm pineapple? Pineapple is delicious cold, but on pizza, he is just not a fan. So for those of you who love pineapple on your pizza, I apologize. So pepperoni out here by itself, we've got a pizza with pineapple on it. The pepperoni is going to replace the pineapple, and you'll end up with pineapple and then a pepperoni pizza. What kind of reaction is that? And then the fourth one, you have a shoe, you have wheels. They are going to combine together and now form a new thing with a roller blade. Okay? You're going to be drawing cartoons like this of your own as a part of an activity I'll explain here in just a moment. All right, then I would like you to try to match these. Can you find the synthesis? Can you find the decomposition? Can you find the combustion, the single replacement, and the double replacement? Okay, so the synthesis one, two things going to one, so that must be this one. Decomposition is where something breaks, one thing goes into multiple, and so that is going to be this one down here. Combustion always needs to have an oxygen and water and carbon dioxide as a product. And so that would be this one. Your single replacement is a single element replaces something in the compound. So here's your single element, here's your compound. So that is your single replacement. And then your double replacement is when you have two compounds or double compounds and things are going to be switching places. Okay, so here is your task. You are going to represent these four types of reactions with a cartoon of your own. So you're going to do a synthesis, a decomposition, a single replacement, a double replacement. We are not going to do a combustion just because those are a little bit more difficult. Okay, so you are going to basically take a piece of paper and section it off into four parts, and then you're going to think about a way to represent a synthesis, decomposition, single and double replacement with a cartoon or pictures of some sort. If you're hand drawing it, color is a great thing for your brain to be able to tag onto. So I want you to make sure that you're including color on any of you guys who are choosing to make your own drawings, which I think is really cool. I'm not awesome at that, so I would probably choose a digital path. So you could use Canva, you could use Google Slides, you could use PowerPoint or any other digital tool that you have that you can use to put pictures together and create some cartoons of your own. You may not use the same ones that I provided. You need to think of something unique to you, not to somebody else. And so you will be graded on accuracy, originality, and just creativity in the cartoons that you are drawing. Okay, so again, synthesis, decomposition, single replacement, and double replacement. All right, so again, at the end of this, hopefully you're able to better identify what types of reactions, when you see a chemical reaction or a chemical equation, can you identify it as a synthesis, a decomposition, a combustion, a single replacement, or a double replacement? All right,